Bismillahirrahmanirrahim. Dear students, our today's topic is probability tree approach. Probability tree approach is basically a graphic or tabular approach for organizing the possible cash flow streams generated by an investment. And these probabilities are shown in a tree like branch of these resembles like a branch of tree, and how we compute the net present value by using these cash flows and probabilities, and how we can compute the uh, net present value, average net present value, and the standard deviation of the net present value. So this one is our data set, that how we elaborate this. Our 240 is our initial investment, and these are the probabilities for year one. This one is our initial probability, and after initially investment of $240, the first cash flow, that is $25% are chances are there that it will be $500. Most likely the chances that it will be $200, and the most pessimistic situation is that it will be negative 100. So it's a pessimistic situation, it's a most likely situation, and it's a pessimistic situation. Optimistic, most likely, and pessimistic situation. And after second year, this one is initial probability. Initial probability. And for year second, these, that again in year second, that after $500 cash flow, there are again three possible chances in year second, that 40% chances that $800 cash flow will exist, the 40% chances that it will be $500, and 20% chances that it will be 200. So it's a branch 1, branch 2, and branch 3 for the first relevant cash flow for year second. And these probabilities for year second are the conditional probabilities. Are the conditional probabilities. So again for most likely situation, against there is a distribution of further probability distribution, it will be 500, 200, minus 100. And for the third pessimistic situation, 20% chances there is a 200, 40% chances minus 100, and 40% chances that it will be negative $400 cash flow. So we will compute the net present value, average net present value, NPV bar. That will be NPVs of all probabilities, joint probabilities, and joint probability. So after this computation, how we will compute this net present value? Joint probabilities are computed by multiplying the initial probability and the conditional probabilities, and then we will go for computing the net present value. And the the standard deviation of the net present values will be computed by this mechanism. Now let we come towards our example, that how we will compute. These are the cash flows, and again further for conditional probabilities are designed here, and the cash flows are depicted here. Now thus our solution step starts from here, in this, from this column, that in first instance we will have to compute the joint probability, and then we will compute the net present value for each cash flow. That how we will compute, that mechanism we have already mentioned here, that how we will compute it for the first cash flow, how we will compute it for next cash flow, we will compute one by one. Then NPVs will be multiplied with the joint probabilities, and then we will get the NPV bar. So then NPV minus NPV bar column is there, then NPV minus NPV bar column square, is there, and then we will compute the joint probabilities multiplied net present value minus net present value whole square. So this column will be, in this column we will report our variance, and then standard deviation, that will be the standard deviation of the this column. Now let we start our computation. In giant probabilities, we will, in first step, we will multiply our initial probability with the conditional probability of first. For first three branches, we will multiply first year probability along with each of these probabilities. Sorry, we will put the dollar sign between C7, and for again second we will 0.25, it is fixed, will be multiplied by second. So we will drag it up to here. So these are the joint probabilities for first three branches. Then again we will use the first C10, and C10 will be continued for the next two probabilities branches, multiplied second branch, and we will take it to three elements. Again for third, we will use 0.25 multiplied 0.2, and we will fix for first last three branches 0.05, 0.05, and when we will make a sum of all these probabilities is equal to sum from this to this value, it will be equal to 1. Now we will compute the net present value. Net present value, we will use the first cash flow, we will discount it, and the second cash flow. For second column, first cash flow will be discounted, then second cash flow. The second step cash flows. First year cash flow for third, and for the second year, third cash flow will be taken. How we will compute here is equal to, we have discounted 8%, is equal to 500 divided by 1 plus 8%. We will power it with year 1. We will close this function to perform the computation, the asked computation. Plus the second year's cash flow, 800 divided by 1 plus I is 8%, and its power is year 2. We will close this function here. D4 will be fixed here. F6 will not be fixed here, but remaining element because it will rotate for each next year. Year 2 will also fixed and initial investment will also fixed. Now see this, how 500 divided by 1 plus 0.8, its power 1, 1 for 800, 1 plus 0.02, its power 2 minus 240, it is 909. And for the second 500 divided by 1 plus 0.08 plus next cash flow of 500, 1 plus 0.08 for 2 minus 200. So it will, we will track it. It is 34 for next cash flows. We will change here. We will track up to here the next cash flow, but we will make changes. We will make change here. It will be D10 and all other values will be remain same for the next three cash flows. And up to here, we will change here D13. And now we have modeled the next cash flows. So these are the cash flows. Now, net present value will be multiplied the joint probabilities is equal to this net present values multiplied joint probabilities. And its sum is equal to sum it is 116.652. And now it is our net present value bar. Average net present value. Now net present values minus NPV bar. And NPV bar is going to be fixed here. Then it's a square NPV is square column. Joint probabilities multiplied NPV minus NPV bar square. We will track here. And we will make sum is equal to sum. is equal to sum these cash flows, and we have here under root is equal to SQRT of the variance 451 is our variance. We make it large. इसको थोड़ा सा बड़ा कर लेते हैं ताकि हमारी वैल्यूज क्लियरली नजर आ जाएं और हमने इसको जो है वो परफॉर्म कर लिए। इस तरह से हम अपनी वैल्यूज को कंप्यूट कर सकते हैं। अच्छा, हमने इन तमाम नेट प्रेजेंट वैल्यूज को अलोंग विद प्रोबेबिलिटीज हम जो है वो शो कर सकते हैं अलोंग विद द joint probability. And we have prepared the net present values along with the probabilities by using joining the joint probabilities and taking the net present values by putting the values into our histograms. Okay, so it's all about our computation that we have computed the in a probability approach then net present value as well as the standard deviation of the product, that how much this product is have its a riskiness. So it's a tabular approach, a graphical approach that we have used to compute the values. Thank you so much.